Good day, everyone. Welcome to part 1B of our third class. By the way, this is Gifted Brain, aka Saizu, first in Africa, sixth in the world. We shall be considering simplification of sword here. Please, I want to say do well to subscribe to our channel and then keep your notification button on so you can get notified when we drop another tutorial video. Now, the basic idea we use for simplification of sword is the principle of addition and subtraction of similar sword. Actually, when we have similar sword, it can be added or subtracted. Now, what actually is a similar sword? The similar sword are sword which are multiples of the same sword. E.g., for instance, root 2, 2 root 2, 3 root 2, 20 root 2. All of these are similar sword because they have the same sword in them. They have the root 2 in them. Same as root 3, 5 root 3, 15 root 3. They are all similar sword. But one thing about similar sword that they can be added or subtracted. Now let's take an example under the simplification of sword now. Let's look at this example 1 now. The principle we apply here is to take each single sword we have here and then express them as products of two numbers in which one of those numbers must be a perfect square. And most likely I will always say, first of all, begin with if 2 can go in the number, again if 3 can go in that number, again if 5 can go, again if 6 can go. We've said this before, if 7 can go, on and on. So the first thing I will do when I have with 20 is to ask myself, can 2 go in 20? Obviously 2 can go in, that is 2 times 20, but none of them, the 2 and 10, 2 in 20 will give me 2 and 10. None of them is a perfect square, so I cannot use 2 and 10. Let's move to another number. 3 is not a factor of 20. Let's try 5. Yes, 5 times 4 will give me 20. So 5 and 4 can go in 20. And one of them is a factor. So I will write as with 20 to be 4 times 5. Now, the next one is the 45 now. For the 45, how do we do this? Again, look for numbers that can go in 45. 2 cannot go, 3 can go, but that is 3 times 15 and none of these two numbers is a perfect square. Let's try 5. 5 times 9 is a perfect square, so I will use that. So that is 9 times 5 now. 9 times 5. Again, plus root 125. What are the numbers that can go in 125? Well, 2 cannot go and then 3 cannot go. You can use a calculator to know all this I'm saying. And then the next one is 5. 5 can go. That is 5 times 25. And since 25 is a perfect square, that's a good factor to use. So I say 25 times 5. And then lastly now, minus 2 into root 80. Obviously, we know that root 80, the factors of root 80 can be 2. 2 times 40. But that will not give me a perfect square. So I can move on to another number. 3, but 3 cannot go. 4, sorry, there is no 4 in my option. 5 can go in 80. That is 5 times 16. And 16 is a perfect square, so that's a good number to use. So 16 times 5. So we cannot go ahead now. 4 times 5 will give me 2 root 5 because root 4 is 5. Minus 9 times 5 will give me 3 root 5. Again, 25 root 5 will give me 5 root 5. And then lastly, we have minus 2 into bracket. 16 times 5 will give us 4 root 5. So that's that about that. We can now go ahead to simplify further. That is 2 root 5 minus 3 root 5 plus 5 root 5. Then minus 8 root 5. And then when we sum this up, since they are similar sword, we would have, so we have minus 4 root 5. We can try the b now. So for the b now, we have 12, 2 root 12. Then this will give us 2 into factors of 12 can be 2 times 6. I'm not going to use that because 2 times 6, we know one of them is a perfect square. Then we can use 3 and 4. So I will add 4 times 3. Again is 48 now. 48 can be expressed as, well, 2 can go 2 times 24, but that's not a perfect square. 3 can go 3 times 16 will give me a perfect square. So I'll say 16 times 3 now. So and so we move further. Minus, for the root 75 now, we would have 2 cannot go in 75, so we try 3 times 25, so 25 times 3. Now what we simply do is to say this is 2 root 2, sorry, that's a mistake, 2 root 3 plus 3 into 4 root 3 minus 5 root 3. And so this will give us 4 root 3 plus 12 root 3 minus 5 root 3. So we have 11 root 3. So you can try the C and then the D on your own, applying the same principle. Well, let's do the C now, but you can pause and take and try on your own and see if you can get what we would get. So for the C, we have 4 root 100 minus 40 root 2 plus root 8. Again, same principle. Let's look at the 200 now can be expressed as what? Well, 2 can go in 200. That is 2 times 100. And that's 100 is a perfect square, so I can use that. 100 times 2. Again, minus 40 root 2 now. That's in its basic form already. And then we have the root 8. It can be expressed as 4 times 2. So we can go again to say this will give us 4 into the bracket of 10 root 2, then minus 40 root 2 plus 2 root 2. And so we can simplify that to say this is 40 root 2 minus 40 root 2 plus 2 root 2. So our final answer will just be a root 2. 2 root 2, sorry. Because 40 root 2 minus 40 root 2 will give us 0. So let's take the last one now. Now for the D, 3 root 18. Well, this can be expressed as 2 times 9. And since 9 is a factor, that is acceptable. So I'll write as 9 times 2. Plus 4 root 48. That is 4 into the bracket of roots. That can be expressed as 2 times 24. But I wouldn't use that because none of them is a perfect square. But we can use 3 times 16. Which is 16 times 3. Then minus root 75 can be expressed as 25 times 3, which is 3 times 25. And so this will simply give us 3 into the bracket of root 3 root 2. 3 root 2 plus 4 into the bracket of 4 root 3 minus, this will give us 5 root 3. And so again this will give us 9 root 2 plus 16 root 3 minus 5 root 3. And so eventually this we will have, would our final answer to be 9 root 2 because they are not all similar surds. So 9 root 2 plus 11 root 3, because 16 root 3 minus 5 root 3 will give us 16, 11 root 3. So that's that about that. Now you can try the following exercises on your own.